the quotient rule. Here it is. dy by dx equals v du dx minus u dv dx all over v squared. And we can only use this rule to find a derivative when the function we're trying to differentiate can be expressed in the form y equals u over v, where u is some function of x, like it is here, and v is a function of x, like it is here. When that's the case, we can say what dy by dx equals using this rule. So let's start with this. Let u equal the numerator. In this case, that's the square of x minus 3. And we'll let v equal the square of x plus 2. Now we need the derivative of each of these with respect to x to use this rule. So du by dx equals, using the chain rule, we bring the power down, so we've got 2. We write out the brackets again, take 1 off the power, that would be a 1 there, and then multiply it by the derivative of what's in the brackets. In this case, the derivative of x minus 3 is just 1. Looking at dv by dx, using the chain rule, we get 2 multiplied by what's in the brackets, take 1 off the power, it was 2, so now it's 1, multiply it by the derivative of what's in the brackets, so that's 1 as well. And now we can write it in this form. So we've got this original quotient here, so that's u over v, using u as this and v as this. So we can say dy by dx, that is the derivative of our original function, equals v du dx, so that's this one here, the square of x plus 2 multiplied by the derivative of u, which is 2 brackets x minus 3, take away u, which is the square of x minus 3, multiplied by the derivative of v, which is 2 lots of x plus 2. And that is all over the square of v. So v is x plus 2 squared, and then we square that. So to tidy this up, we look for common factors of these two halves that we've got here of the expression on the numerator. So I'll write dy by dx on the left hand side. I'm looking for common factors. We have a 2 as a common factor here, so I'm going to take that out of the brackets in my first expression on the numerator. And what else have we got? We got an x plus 2, that's in both, and we've got an x minus 3 in both as well. So I can take these 3 factors out. What's that gonna leave me with? Let's have a look. So 2x minus 3 has come out as a factor, and x plus 2, so that just leaves us with x plus 2 here. So multiplying these two terms together will give me the squared, and then the 2x minus 3 is there. Take away, and here we've got a 2x plus 2, there it is, and then we've got another x minus 3 here, and that is all over, these are the factors that I took out there, it's all over x plus 2 to the power of 4, which is the square of the square. Now this equals, we've got those factors on the top. I'm noticing we can cancel 1x plus 2 here with one of the x plus 2's here. This is the product of x plus 2, x plus 2, x plus 2, and x plus 2. So we've got this 2 on top. We've got an x minus 3. And what does this become? Well, we've got x minus x, so that's 0. and we got 2 minus minus 3, which is plus 5. So 2 minus minus 3 is 2 plus 3, which is 5. So we're just left with a 5 there. And that is all over x plus 2 cubed, because I cancelled one of the factors x plus 2 here with one of the factors x plus 2 here. And then now I just need to find the product of 2 and 5 to tidy this up, which will give me the final answer. Let's write it here, shall we? dy by dx equals 10x minus 3 all over the cube of x plus 2. And there's my final answer using the quotient rule. Here's a second example. We're going to find the derivative of this one, x over root 1 plus x squared. And we've got this rule here, the quotient rule, to do that. So if y can be expressed as u over v, where u is a function of x like it is here, and v is a function of x like it is here, then we can use this rule. So we first say let u equal the numerator, in this case it's x, and we'll let v equal the root of 1 plus x squared, which is the denominator. I'm going to write that as a power, because I find it easier to deal with when we're differentiating. Now we need du dx, that's the derivative of x, which in this case is 1, and we need the derivative of v, that's dv dx. And we need the chain rule to do that. So we bring the power down, that's a half, right in what's in the brackets, 1 plus x squared. Take 1 off the power and then multiply it by the derivative of what's in the brackets, in this case 2x. Now we have the different components to substitute into the quotient rule. So we can say dy by dx equals v du dx, well there's v, so that's 1 plus x squared to the half, multiplied by du dx, which is 1, take away, minus u, which is x, multiplied by dv dx. I'm just going to simplify this by saying a half multiplied by 2x is just x, so I'm going to multiply dv by dx is going to be x brackets 1 plus x squared to the minus a half, and that is all over v squared. Now we've got a square root of 1 plus x squared here, and when you square a square root you get back to where you started. So we've got a 1 plus x squared as our numerator. Now we need to sort out, sorry, that's the denominator. Now we need to sort out the numerator here. So dy by dx equals, I've got the square root of 1 plus x squared. I'm going to take away x squared lots of this here. Actually, I'm going to write that underneath. So let's ignore that line for a second. 1 plus x squared square rooted. And that's our numerator. And the denominator is 1 plus x squared. So I need to find a common denominator to collect these two together. So we just consider the numerator for a moment. dy by dx is 1 plus x squared square rooted multiplied by 1 plus x squared square rooted over 1 plus x squared square rooted. So we're effectively multiplying it by 1 in this bit here, and then we can take away the x squared over 1 plus x squared square rooted. There we go. And then of course that's just the numerator of our expression from the quotient rule, so our denominator is 1 plus x squared. And now here we can add these two fractions. Multiply these two together, we're left with 1 plus x squared. We take away an x squared, and that leaves us with just 1 as our new numerator. So dy by dx equals 1 as our new numerator of the numerator. So that's 1, and then over the root of 1 plus x squared. And then we're going to have that as our numerator over 1 plus x squared. Right, we're nearly there. So this is the same as 1 over the product of these two. So here we've got 1 plus x squared to the half, and here we've got 1 plus x squared to the 1. And if you add those powers, you get 1 plus x squared, 1 plus x squared to the 3 over 2. That power, let's write that again. That's 3 over 2. It comes from the 1 power here and the half a power here. Let's just be super clear and write that out again. So that's 1 plus x squared to the 3 over 2. And that's the derivative of the original function using the quotient rule.